In this session, we're going to look at lessons 21 and 22. Starting off in lesson 22, we're going to be looking at functions. And a function is everything over here on the right side of this equal sign. You're going to plug in for a value of x, whatever they tell you to find. And what this says is the function of x is this. So this right here is the function. Anything on this side of the equal sign, it's not an equation, it's a function. And they want you to find f of 5. So basically, 5 is x. So f of x equals, and in place of x, we're going to put 5. So the answer to f of 5 is going to be 25 plus 5 minus 10, which f of 5 is going to equal 20. And that is your answer. Don't be intimidated by this f of x over here because it's not a part of the equation. Over here you have f of x equals x squared plus 1. And they're saying that they want you to find f of x plus 2. So in place of x, you're going to put f of x plus 2. So over here on the right side, the function that we're going to plug into for x is x plus 2. So we'll have x plus 2 squared plus 1. Remember, when you square something, it's x plus 2 times x plus 2 plus 1. So you get x squared plus 4x plus 4 plus 1. So you get f of x plus 2 equals this answer right here. X squared plus 4x plus 5. And so that is the answer to that function there. Continuing on to the second part of lesson 21, we see more on functions and we see domain and range. And so how to find the domain of this. Now if you'll notice, this is the function, f of x is, and the function is the square root of 10 minus x. And they want you to find the domain of f. In this type of problem, you're actually not solving for something, but you are critically thinking through what x cannot be. Okay, and there's really only, they're going to give you several different versions of these, but there's really only two types. There is a radical and then a denominator type. In the radical type, and your answer is going to be something like x is a member is written like that. X is a member of reals, and then you're going to say x is, and you're going to come up with that. Now, whenever it's a radical, in order to be a real number, you can't get square root of negative something. You can't get a negative number because this is an imaginary number, right? That would be an I. This would be an imaginary number. And so therefore it's not a real number. You can't graph it on a number line. So what we've got to figure out, anytime it's the radical type, you've got to figure out what would make this not a negative number. Well, as long as x is 10 or less, so x has to be less than or equal to 10. X actually can be a negative number. So if that was like negative 1, it would be plus, it actually become a positive 1, so it would be root 11. So x could be negative, but the outcome of the radical can't be negative. So the answer to this one is x is a member of reals, and x is less than or equal to 10. So with any one of these where you're finding the domain of f, and it's a radical, the key is the radical can't be a negative number in the end, negative answer. Looking over at this next type, when it's in the denominator, what x cannot, or what the result cannot be, it can't become 1 over 0. So any number that would cause the denominator to be 0 is going to make this invalid. So as we look at this one here, it's x is a member of reals, and what you're going to say is x is not 2. Because if x is 2, it becomes 2 minus 2 which is 1 over 0. So your answer is x is a member of reals and x cannot be 2. So that's how you solve for those. We can look at more at those in class, but that's the gist of those problems. Actually, before we moved on, I want to look at this. This is another type. This is probably the ones you're going to be getting more often. This is where they combine the two, where they combine the radical and the denominator. So what you're going to say is f of x is x, say it like this, x is a member of reals, and do it like that. It's got to be both stipulations. So on top, x is greater than or equal to 0, because it can't be a negative number, it would be a negative radical. And then also, x is, actually that would satisfy it, because x can't be 2. Well, 2, oh no, it's got to be both. So x is greater than or equal to 0, and x can't be 2, because if x was 2, it would give you 0 in the denominator. So you can't have 0 in the denominator, and you can't have a negative radical. So these are the two stipulations to the domain and range of this problem. The next one that we're going to look at is found right here on page 156, and you see all of these circles right here. And you could look at your book, or obviously you can just look at this book. But the key to these is you got to determine if it's a function or not a function. And what makes this a function is you're plugging these into a machine and you're getting an answer. Well, you could plug 3 into the machine and get 3. You could plug 4 in the machine and get 3. But what you can't do is plug 5 in the machine once and get 3, and 5 in the machine a next time and get 4. So these guys can share the same answer, but these guys can't have two different answers. So this is a function, this is not a function, this is not a function because M does not have an answer. Anytime you plug something in a machine, it's got to get an answer. And then this one is going to be a function here. In lesson 22, we're going to look at the first part is graphing absolute value equations on a number line. You look at this first one, we have the absolute value of x minus 2 is less than 0. The key to graphing any of these, the first thing is the absolute value needs to be isolated by itself. So you bring the negative 2 over, it becomes 2. And what you have to do inside the absolute value is make it 0. And this is easy, you're just going to 0 is just plugged in, there's no math to do. And whenever the absolute value is less than a number, it's going to be a conjunction. Less than is a conjunction. Greater than, absolute value is greater than, it's going to be a disjunction. And so the number on the left is going to be the origin. The number on the right is going to be the distance. Okay? So if the origin is 0, the distance is 2 either way of 0. So we'll go 1, 2, and we'll go 1, 2. And it's a conjunction because it's less than. It's going to be empty, empty. Conjunction means in between the 2 points. So just to review, the absolute value is the origin. Number to the right of the inequality is the distance from the origin either way, positive and negative. Because it's less than, it is a conjunction, which means it's in between 2 and negative 2. Because there is no equal to, it's an empty circle. So this is how you graph that one. Look at the next one. The absolute value is already isolated. You don't have to isolate the x. You just have to isolate the absolute value. And so whenever you set this equal to 0, x would have to be 5. 5 minus 5 is 0. So 5 is our origin. So we're graphing it. 5 is our origin. Our distance is 2 either way. So we're going to get 7. And we are going to get 3 because we're going 2 either way. 5 is the origin. It is less than 2. So just like this one, it is a conjunction. And there is no equal to. So it's going to be in between these two right here. And for our last one, the absolute value is already isolated. The origin, it's going to be -2 right here. So the origin is -2. We're going to go 3 either way. So we'll go -1, 0, 1. We're going to go -3, -4, -5. And it's going to be equal to, and it's greater than, so it's actually going to be a disjunction and go outward. So these are the 3 ways to graph the different types of absolute values. They actually give you one more type in your book. You could graph this one in your calculator, which is good, and you start getting good at that. But it's y equals the absolute value of x. When you punch it in your calculator, it's going to look just like this. And this is all you would have to do to graph this right here. Not too tough. Throw that one in your calculator. Last thing we're going to look at on lesson 22 is this top one where it says, sketch the graph to the function y equals 1 over x squared. What you're going to do is you're going to put that one in your calculator and graph it. When you put that one in your calculator and graph it, what you are going to get as your answer is this right here. That obviously has a little bit of a round to it. So with those types of problems, it's a calculator problem. You just plug it in and graph. If you don't know how to do that, we'll look at it in class on Monday. That's it for lessons 21 and 22. Not too bad.